The periodic table is arranged by increasing atomic number and atomic mass. Today I'm going to teach you how to read individual elements. We're going to use hydrogen. So hydrogen's atomic number is 1, and that's what goes at the top. It's at the top left of the periodic table. Hydrogen's symbol is H, and that's what comes next. Then you write the name of the element, which is hydrogen. And then at the bottom, you put the mass. The mass of hydrogen is 1.008. How you can determine the protons is by looking at the atomic number of the element. So for this example, we would have 1 as protons. By telling the neutrons, you would subtract the atomic mass of the element from the atomic number. So we would get 0.008 for the neutrons. Electrons are the same as the atomic number unless there is a charge given to you. And since there's no charge, we get 1.
Hey, I'm going to teach you about the solubility rules that you can find on the last page on the top left-hand corner of your periodic table. There are many rules that you have to follow to figure out if it's soluble or insoluble. I'm going to show you one problem today, just with a couple of rules. And for the problem, you must have a double replacement in order to do the solubility ones. So for this problem, in your reference packet, if it's soluble, it's always going to be aqueous. And if it's insoluble, it's always going to be a solid. Where you have to look at the rules on your reference packet. And you look at the second part, but these first two are always going to be aqueous no matter what. For the products, this is a chloride, and it says, the rule right here says all chlorides, bromides, and iodides except silver, lead, and mercury. And that's silver, so that makes that insoluble, which is a solid. That's a nitrate, and in one of the rules it says all nitrates, acetates, ammonium, and group 1A salts are aqueous, which is soluble. And now your second step would be to determine, or to balance your equation. After you have determined if it's aqueous or soluble, you're going to balance the equation, and then you're going to solve. And that is how you use the solubility rules on your reference packet. Today I'm going to teach you how to use the activity series that is located on the last page of your reference packet, like on the right side. Okay. When you're doing a single replacement problem, you have to use the activity series. And for this one, halogens are going to replace halogens, so I and F2. And if the element that is alone is higher on the activity series than the element that is bonded with another one, then the reaction will happen. If it doesn't, then it will not, and I'll show you that in the next example. Both of these are halogens, so they replace each other. And F2 is above I, so it will replace. And you get HF plus I2. And you have to balance the equation. And there's a 2 in front of this, and a 2 in front of that. And now for one that you, a reaction that will not happen is going to be this one. And there are 2 metals replacing each other. So Sn and Ba, if you look on the periodic table with your activity series, Ba is higher than Sn. And since Sn is the one alone, that one, in order for the reaction to happen, it needs to be higher than Ba, but it is not, so the reaction does not happen. So if you yield it, it is no reaction. Today we're going to learn volume of 1 mole of gas at STP. STP stands for standard temperature and pressure. The STP of pressure would be 1 atm, and the STP of volume would be 22.4 liters. And we're going to do an example. So you're given 0 degrees Celsius, and it says at STP. So you always convert your Celsius to Kelvin, and your Kelvin is always going to be 273. And your STP of your volume over here is going to be 22.4 liters. You are given 91 degrees Celsius, and you have to add 273 to go from Celsius to Kelvin, so you get 364 Kelvin. And it's asking you what would the other volume be. So for the problem, you would put 22.4 liters, because that's your standard temperature pressure, over the temperature that you're given, equals the volume that you're looking for over your temperature. And then you cross multiply, and then you divide, and you get your volume that you're looking for is going to be 29.9 liters. And that's how you do standard temperature of pressure.
Today I'm going to teach you about the Bohr model of the hydrogen atom. This model can be found on page 8. It is the top part. The Bohr atomic model states that electron travels in orbits around the nucleus. The larger the orbit, the greater the energy state. As we look at the Bohr model for the hydrogen atom, the middle is the nucleus, and the rings around it are the different levels. Energy levels close to the nucleus, however, have a lower energy than the outer levels. If we were given a question like this one, which wavelength is given off if a hydrogen atom fell from the first energy level to the fourth, we would have to look at the Bohr model and find the first energy level and the fourth energy level, and we'd have to go down the line and see that it gives off a 97 wavelength, which is UV rays. So, and that is how you read the Bohr model. Today I will teach you about the temperature formula, and this formula can be found on page 1. It is behind the periodic table. It is in the first block, and it says standard temperature 0 degrees Celsius or 273 K. K stands for Kelvin. So standard is 0 degrees Celsius or 273 Kelvin. So using the formula 0 degrees Celsius is equal to 273 Kelvin, you can determine how many degrees Celsius is in Kelvin. So for number 1, you are trying to find 50 degrees Celsius is equal to how many Kelvin. So what we have to do is you have to add 273 to 50 to equal 323 Kelvin. Now sometimes you have to go backwards and you have to see how many Kelvin is in degrees Celsius. So what you would have to do is subtract Kelvin from 273. So you're given 500 Kelvin, and you have to subtract that by 273, which is equal to 227 degrees Celsius. And that is how you use the temperature formula. Today I'm going to teach you about the density formula. The density formula is D equals M over V, or D equals density, M is mass, and V is volume. To find this equation, it is on page 3 of the reference packet. In this question, you are given 60 liters, 18.016 grams of H2O, and you're trying to find density. So liters is the unit for volume, so you'd put 60 on the bottom, 18.016 grams of H2O. Grams is the unit for mass, so that would be on the top. And you're trying to find density, which is over here by itself, so you have to equal that. And then you have to divide 18.016 from 60. That would be 0.3003. And make sure you don't forget your unit. So your unit would be grams over liters. So your final answer will be 0.3003 grams over liters. And that is how you find density and what the density formula is.
When predicting the products of the equation, you turn to page 6 of the reference packet. In an actual reaction, A and B are elements and they yield to form a compound. So as an example, aluminum plus sulfur would yield to be aluminum sulfide. For decomposition, the opposite of synthesis, your compound will be on the left side, or the reactant side, and it will decompose to your two elements. In a real equation, NaCl, or sodium chloride, would decompose to Na plus Cl2. For a single replacement, you are going to have an element and a compound yielding to an element and a compound. So A would be your element plus BC yields to AC plus B. Realize how my A replaces my B. When finding out if an element replaces another, you have to refer to the activity series. So I replaces F. So your product would be HF plus I2. Double replacement, you will have a compound plus a compound yields to a compound plus a compound. AB plus CD yields to AB plus CB. A replaces C and B replaces D. For an example, magnesium bromide plus potassium nitride yields to magnesium nitride plus potassium bromide. A metal replaces a metal and a non-metal replaces a non-metal. Hydrocarbon plus oxygen yields to carbon dioxide plus water. For an example, C2H6 plus O2 will yield to CO2 plus H2O.
This is the electromagnetic spectrum. It's found on page 8. The electromagnetic spectrum is used to organize all the types of electromagnetic energy that exist. Each electromagnetic wave emits a different level of energy. The higher the frequency of the wave, the greater the energy. Frequency and wavelength are inversely related, so a wave with a high frequency has a low wavelength. For example, which type of radiation has the longest wavelength? If you look at the spectrum, you'll find out it's radio waves because that's where they are on the electromagnetic spectrum. When you can't find an element on the periodic table, that means it's probably in the polyatomic ion chart, which is in the very back of the review packet. This is where you can find different compounds that are used in chemical equations and find out what their charges are. For example, we can use this chemical equation of decomposition to find out how to find the charge from the polyatomic ion chart. Be is an element that you can find on your periodic table. The charge of this is +2. To find out the charge of the polyatomic ion, you can look at your chart and find OH. Beside it, you will see that it has a -1 charge. By crossing over the charges, you'll find that this compound is BeOH2.
When looking at the melting points and the boiling points in your reference packet, you would see that it starts from a solid, and then it melts, and then it goes to a liquid, then it boils, and it ends in a gas. So if a question were to ask you what is methanol at -173 degrees, you would look at your reference packet, and you would see it goes in between -182 and -164, so it's a liquid. Using Avogadro's number, you would turn to page 1 in the reference packet. Avogadro's number is 6.02 times 10 to the 23rd particles over mole. Avogadro's number is used specifically for atoms, ions, molecules, and formula units. If a question were to ask you, how many calcium ions would it take to make up 50 grams? You would see that it says ions, so you have to use Avogadro's number. Start off with 50 grams of calcium with a +2 charge, since it's an ion. 1 mole over 4.08 grams calcium. And then you would put Avogadro's number up top, since you are looking for ions of calcium, and on the bottom 1 mole. And your answer would be 7.51 times 10 to the 23rd ions of calcium with a +2 charge.